Good morning, it's Mr. Glenn, and we're going to take a look at Lesson 33 today. The biggest part of Lesson 33 centers on this inequality, and it's just C is less than or equal to -9. So I hope everybody can see that. After we talk about solution sets, which are sets of numbers, and a solution set all the numbers have to be true for the solution set to be valid. So I want to remind you of that fact. After we talk about and take a closer look at C is less than or equal to -9, we're going to talk a little bit about plotting on a number line. So let's first, Ms. Wagi and I had mentioned before that when we're looking at inequalities with a variable, the easiest way to help visualize your inequality is to draw a number line. So let's draw a number line. Bear with me. My lines are not as smooth as they could be. So here's a 0. And then down here at the other end, we're going to do -9. And if that's -9, this would be -10. Then halfway between the two, here's a -5, and so on. You kind of get the idea. So here's a number line. This continues. So let me continue this out, right? And this is a number line, so it continues both directions. I lost my cursor. Where are we? Here we go. All right, so solution set A on the first quick review problem on lesson 33 says solution set A, the values are -8, -7, -6, and -5. So if you look at our number line that we plotted, -9 is way over here. And I just want to remind everybody that all values to this direction to the right are greater, right? And then all values in this direction of the value are less. So if you look right here at the number 0 and we plotted a 1 here, you know that 1 is clearly greater than 0, right? So just remember, all numbers to the right are greater, all numbers to the left are less. So look at the first set. It said -8. That would go here. -7, that's our second value. -6 and -5. All these values are to the right of -9. Therefore, they are greater than -9. So the interesting thing is that solution set A with -8, -7, -6, and -5, solution set A is invalid. So we're going to strike through that. Let's take a look at solution set B. Solution set B starts with -12, which would be clearly out here on this end of the number line. So if it's to the left of -9, and again we know that -9 is right here in this area. So we got -9 right here, and we know that, hey, the first value, -12, is to the left of -9, therefore it is less than. So let's look at the next one, -11. -11 is also out here to the left of -9. So -11 is less than. -10, and then -9 is equal to, so we know that the second part of the symbol is that C is less than or equal to -9. So all values to the left of this are going to be less than C, which is -9. I mean, all values of C have to be less than or equal. So therefore, solution set B is true because they are all either less than or equal to -9. Next section, let's take a look at solution set C. Solution set C is 10, 11, so these are all positive numbers. 10, 11, 12, and 13. So we know that all of these numbers, without even plotting them, are going to be farther, they're going to be clearly to the right of -9. So solution set C is not valid. And I'm going to fill these in for solution set A. We got -8, -7, that's a -7, -6, and -5. So solution set A, they were all also to the right of -9. Solution set C, they were all right. So both of these are not valid, so therefore they are not going to be selected. So take a look at solution set D, and it starts with negative 265, and it goes all the way down over to the number negative 10. So just for kicks, I'm going to skip these numbers in between because they're all between the value of negative 265 and negative 10. Negative 10 is clearly to the left of negative 9. Therefore, solution set D, all four values are also viable. So therefore, solution set D is also valid, so we're going to select it. So in this group, we have we have set B, which was 12, negative 11, negative 10, and negative 9. So solution set B and solution set D are valid. So that's the review. That's the quick review. Only set B and set D make this statement true. So therefore, those are the only ones that make this statement true. Therefore, those are the only ones we set. Now, if you look down to the next part in the box, it just talks about how do you graph a solution. So we can graph this by selecting negative or equal to number 9. We're going to put a dot right here because we say everything that equals number 9. So negative 9 is going to be true. So this dot is solid. And so we're going to fill in a dot right at 9. And then we would make a line on top of the number line. So that means that any value to the left of negative 9 is going to be true. I keep erasing that. Sorry, folks. That's such a good arrow going there, too. So all values, and then this is how you would plot it. So that's the main point. We have problems number 1 through 6 to do. And all you have to do is select the number lines that are true. The main point is with the number line, if you have a solid dot, then your inequality has to be greater than or equal or less than or equal. And if the place where your number line is that starts right here where the value is has to be either greater than or less than, because this means it doesn't include that value. And we'll talk more about that tomorrow. Take a look at numbers 1 through 6. Take your time, and remember the critical point is this rule right here, that if you have a solid dot where you start your number line, it has to be greater than or equal to or less than or equal to. And then if you have a hollow dot, then that means it doesn't include the numerical value corresponding with your statement, your inequality statement. So there's not going to be the equal sign involved. Thank you very much. I hope you had a great day. And remember, take a look at the main page to check out when our office hours are. So have a great day.